Nice. Welcome to All Understand family. Today topic is DAC interfacing with 8086 using 8255. We know that in a communication requirements, in a communication need, it is very most important to satisfy the input signal and output signal. How it is, the input signal which is converted by ADC, nothing but to digital form, and the digital form will be transmitted over a long distances. Why? Because the digital signal does not don't lose the energy even though it is transmitted over long distances. Automatically the user required analog signal at output end, so the DAC is required to convert the digital signal to the analog signal. Now in this video we'll discuss how the DAC interfacing using 8255 with 8086 latest microprocessor. Let us see. Now we can understand that there is a DAC. The DAC has a very simple 8 bits which is taken as input from the 8086. Obviously we know that the remaining pins are reference, V plus and I out. Remember that whatever the input signal obtained from the 8086 is converted to the output analog form that is available at I out 1, I out 2. Let us discuss one by one. See there, we discuss here the 8255 as a 3 ports. We don't require all 3 ports, we require only one port, that port A. This port A is act as an output port and this will be given to the input of all 8 bits. So this entire digital signal after a long transmission has been completed, so it could be converted to the analog signal for the user to operate any TV, mobile, whatever the device at the output side, that can be done by this converted analog signal from the digital form. So this is, remember that once again I'm saying that, dear students, here the conversion is done by DAC but not at all. The conversion is done by the 8255 IC. 8255 IC is only used for the connecting or interfacing with the 8086 and DAC converter, nothing but digital to analog conversion. So this is the thing. So now let us see how we can find it. So the converted signal which is in analog form available where? At output terminals I out 1 and I out 2. By using op amp, this will be converted the current signal to the voltage signal, and that can be used for any operating device at the output side. Nothing but just we discuss mobile or TV or any apparatus. So this is the entire interfacing of a DAC for the given input digital signal and converted to output signal. See there, the DAC converts the digital input into analog output by using one simple technique that is called as a R2R ladder circuit. There is a different techniques, weighted resistance method and so on. Here I discuss how the conversion, the digital input given to the DAC, how it will be converted to digital form, R2R ladder circuit. See there, R2R ladder circuit. This is R2R, R2R. All these circuit components is get the input from the digital form, that is see there D7, D6, D5 to the D0, all 8 bits digital input. So here it is 2 power 1, 2 power 2, 2 power. Remember that, dear students, once again remember that when we derived the equation for the analog to the digital signal, we have to take care about it is not a d to the power of 8. It is the first bit d power 1, d power 2 power 2, 2 power 3, for the starting higher bit of a D7. So this is, we have to remember carefully, this can be used by the R2R ladder circuit. Now this is the output voltage we obtain for the digital D7 to D0 8 bits. See there, for example, I have taken the digital input 1010, the lower bit is all zeros. Let us see what is output. See there, D7, what is D7? 1 by 2 power 1. D6, 0 by 2 power 2. D5, 1, that is 1 by 2 power 3. So remaining all are zeros. So what is the value got it? 7.5 volts. The digital input is converted to the analog output by using the DAC. So this is the DAC conversion operation. Once again I am repeating, students, you please understand carefully. The DAC is converting the digital to analog output, whereas the 8255 is used for the interfacing. Nothing but connecting the DAC and 8086. This is the thing. Now let us see the program. How we can obtain the program to interface 8255 with a DAC. It is very simple to understand how it is. Let us see from the basic of a ALP, assembly language program. We know that assembly language program has a starting steps, assume directory. From that we can start the instructions and we can complete the entire programming code. So in between start to the end, we can write down the number of instructions. Instructions 1, instruction 2, instruction 3, and so on, n number of instructions you can write down. So what is instruction? Instruction consists only 2 points. First point is the very simple, that is mnemonic. What is second point? Operand. So what is a mnemonic? Whatever the operation we are carried over instruction, maybe add, move, shift, and so on. So many mnemonics are there in the instruction set of 8086 that I don't discuss now. Just only I'm review the basics of writing the programming. Now what is operand? Operand is the simple thing. It can be a data, it can be a register used in the program, it can be a address or memory location. So any of these three is a operand, nothing else more than this. So any programming language, ALP, assembly language programming, has these 2 points. In that, one is mnemonic, other one is operand. So let us, I gave the example for the mnemonic add operation, whereas the operand for data, this is the 2 data is adding. For register also I gave the example, AL is a register. The 80H is directly loaded into the register AL, accumulator register AL. Maybe AH. AL stands for lower byte, H stands for higher byte. We can use AX also, both. All 16 bits can be moved into the AX. Like that we can use the register. Next, one more address location or memory location. How it is, we can kept in the square brackets. It means that it is not a data, it is the memory address location. The content of a memory address location directly moves to the register AX. So this is the all examples for the operand I presented here for the understanding the basics of a ALP, assembly language programming. Now let us go for actual programming of a DAC, digital to analog converter. Dear students, you please understand that here it is very simple, only 2 steps you have to understand to write the programming code. Now let us see how to start the programming. See there, the first instructions are having a control word. What is control word will do? 8255, how it is interfacing, whether the 8255, how many ports are using, which port is output, which port is input. Here what is that CWR? Only one port is using, that is output port. So what is the control word? We can calculate 80H. How it is? Let us see how it is. The control word is 80H. See there, this is our control word calculation or computation. So we have 8 bits. In that 8 bits, the most bit is the 1. What is the mode of operation? IO mode operation. That's why 1. What we want? Only port A. See there, this is the port A. What it is? Output port. So it is 0. Remaining don't care. No need of taking port C, port B, because only one port is required for the DAC conversion. Nothing but analog to digital conversion. Only one port is we are using. So what is the control word? higher byte is 100, 2 power 3. 2 power 3 is but 8. This is all zeros. So 0. 80H is the control. That is control word. This control word is loaded into the control word register by using the accumulator. So this is the simple initiation of our programming to interface 8255 with what port we are going to be used, for what purpose we are using, whether input or output. This is completed. Now I said now only 2 steps is required for understanding the DAC interfacing. How now we will see the first step. So what is the analog signal? I am taking the triangular wave is the one analog signal. So we know this, what is the triangular wave has? One rise and fall, one fall. So this will be repeat over a long period. So if you can able to write down the logic for rise and also fall, then it is sufficient to write down the assembly language program in the 8086 programming. See that how it is rising, starting from 0, step by step, +1 I am adding, incrementing 1, and it is going to the highest value EFF. So this is the simple logic we have to write down in the programming. This logic how we can implement, let us see. See there, we are using the output port A. So the accumulator register will be writes into the port A, output port A. So port A is used as a output port. Now see there, what we are going to be used. Already we start accumulator register is initiated at 00. See, it is initiated at 00. So to complete the rise portion of a triangular analog wave, what it is required? We have to increase 00 to 01. One increment we required. So increment AL. So AL is incremented 00 to 01. See there, 00 to 01. Now we are comparing with what? Highest value of a rise portion. What is that? FF. So we are comparing this 01 to FF. What happened now? It is not compared. It is a 0. See there? Jump no 0. If there is no 0, what happened? This loop is repeated one by one with the increment 1 by 1. So first increment is 1, second increment is 1 plus 1, 2, third increment 2 plus 3. Like that this loop is increasing until up to it is reached to the highest value of a EFF. At last step, what happened now? This EFF is equal to the last value from 0 to FF. Both are equal. Now what happened now? The compared output, there is a jump. No 0 is not satisfied. Nothing but it will come out from the loop. Nothing but the raise portion loop is programmed by using until up to the entire 0 to FF. This is I labeled as a wait 1. You can label as this is loop 1 or L1 like that in your own words. So I represented here the first loop is wait 1. Now in the wait 1 loop, what happened now? Raise portion is achieved. Now next, what is our next step? To obtain the analog triangular output, we required fall. See there, the fall from F to the 0. Again it is falling also step by one step, second step, like that. FF to FE, FE to FD, like that until up to 0. What happened now? Highest value will be decremented by 1. So we are going to be use here decrement. So let us see what is the second loop for the fall portion. So this is the fall portion. How it is falling? FF to FE, FE to FD, and so on until up to 0. So let us write the second step of a analog output, how we can achieve. So we can create the same loop but not increasing, with a decreasing. That is the only simple logic. You can easily write down the second step. See there, our output port is A, accumulator is loaded with a output port A. Next one is we are decrementing the AL from where? After this loop is over, what is the latest accumulator resistor value? EFF, peak value, maximum value of our what is called a signal. So maximum value of signal is what? EFF. So this will be compared with what? FE, first step, decrement. So it is not compared, nothing but there is a no zero. What happened now? Second loop will be repeated. Wait 2 loop will be repeated. I said once again, if you want, you can name as this label as a loop 2 or L2, like that, according to your wish. So this is the simple loop 2 for the following portion. It will be compared until up to the 0 0. When 0 0 achieved, what happened now? This loop will be satisfied and it will come out of the loop. See that when it is come out of the loop, what we want? We want one more rise, one more fall to continue the triangular wave analog output. So for that reason, what we can go? We can go to the loop 1 again. That I wrote in the last sentence. See there, the students, now here the entire program is over. The loop will be continue until up to the power is on for the microprocessor, and the analog signal will be obtained at the output side. So this is the entire operation of a interfacing ADC with the latest computer 8086. Thank you one and all. Thank you all.